Welcome to New Frontiers, a show that's all about exploring the science, discovery, and innovation happening right here at the University of Arizona. I'm your host, Erika Hamden, and today I'm at the Kuiper Space Sciences Building, home of the Lunar and Planetary Laboratory. This is one of the world's largest programs dedicated exclusively to planetary science at a university. And some of NASA's most historic missions have been spearheaded right here. For this episode, we're going to look at some of the most recent missions to explore near-Earth asteroids. These are the rocks from space that could one day threaten our planet, but they can also hold clues to the origins of our solar system. So let's go. First, I'm on my way to the Astromaterials Analysis Lab, where we'll get to look at actual samples from a billions of years old asteroid. The samples were returned last September as part of the U of A-led OSIRIS-REx mission, the first time that NASA has brought back samples from an asteroid. Our cameras have been with that mission since its inception, and of course, had to be there for the conclusion. And the conclusion was thrilling. Check out our story on it, and then meet me afterwards in the lab where we'll do our own analysis.
Welcome, and thank you for joining us live from the Army's Dugway Proving Ground in Dugway, Utah. This is special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. In just a few moments, we're going to hit that key milestone of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range.
EDO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. This is from our infrared tracking camera on the WB-57, our high-altitude plane. Getting a great view of that SRC heating up as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. Very quickly in, we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and makes sure that we are continuing to target that landing ellipse.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. We continue to track with our high-altitude camera here.
The only thing that I needed to know was that parachute deployed, so obviously I was keyed into that more than anything.
I've had a lot of heart-pounding moments, yeah. I often ask myself, how many can you hand in one lifetime, right? It's like, I think I might be hitting my limit here.
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REx.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
For the actual launch, it was just transcendental. Like it was a true out-of-body experience. It was like I was there with OSIRIS-REx as we lifted off, into the stratosphere, into orbit, and then that final burn, which sent us off into the solar system. And I was like, fare thee well, man. We got an adventure ahead of us. It's just beginning.
AP vanished. Centaur is now orbital.
We've worked hard to get to this point. The best times are ahead of us. We are going to get to asteroid Bennu. We're going to map it. We're going to pick that site. We're going to get that sample, and we're going to bring it back to Earth.
And then the moving dot here is actually the asteroid.
Monday, December 3rd, 2018, the spacecraft ends its approach to Bennu.
We have arrived.
It's an amazing time right now. The spacecraft is working, the camera is working, everything looks go to get into the science campaign. So the winner of the OSIRIS-REx Site Selection Championship is the Nightingale site. All right. We're feeling pretty good. Everything's gone really well today. Earlier we departed our orbit around the asteroid, so we're flying over the sunlit side of the asteroid. The spacecraft has deployed its robotic TAG-SAM sampling arm, so the arm is ready.
OSIRIS has descended below the 5-meter mark. The hazard map is go for tag. Contact expected in 50 seconds.
We're going in. We're going in.
And we have touchdown!
Touchdown declared.
So Bennu has surprised us every step of the way, and sure enough, we went down into the asteroid this deep. We collected so much material, it was leaking, and particles were just spewing out into space. So one last emergency, no worries, we'll figure it out, and we quickly got that sample stowed, tucked away into that capsule, and closed up and ready for its journey home. We want people to realize the impossible, to see what you can do creatively, constructively, when people come together.
We are here at the Utah Test and Training Range. In less than an hour, a 4.5 billion-year-old piece of the ancient solar system will be landing here in the desert. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. The sample will touch down in our landing ellipse about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us where the sample will end its journey today. We've got a lot to discuss and a huge adventure straight ahead. This is live coverage of NASA's OSIRIS-REx sample return.
The day actually starts really early in the morning, and there's a critical decision at 2 a.m. Go, no go. Are we releasing the capsule, or are we in a situation where we have to hang on to it and delay the sample return by 2 years?
Yeah, okay.
I voted go, so that's on record. PI's go, right? But I don't get the safety vote. And then there's a whole series of commands and operations that happen to the spacecraft, ultimately releasing the capsule where it hits the top of the atmosphere about 4 hours later.
Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft. And I'm very happy to report that they gave the green light, they gave the go command officially. And in just a few moments, the SRC itself will be streaking across the skies as we begin to track it.
That's when the field team activates. We arrive here at the Michael Army Airfield, and we get into our helicopters and we fly off to just outside what we call the landing ellipse. And then we wait until we get confirmation that we can see the parachute opening up. This is where the final end game of OSIRIS-REx plays out.
So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment.
See on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
Start your stopwatch right now. We have that expected milestone of entering into the Earth's atmosphere. Phenomenal view of that streaking SRC coming in across the sky.
At the end of the day, we know we've done the best job we can, but the thing I worry about the most is we have to power up the sample return capsule. And there's a battery system on there, which we haven't talked to, which releases the parachutes. So if we try to power up the batteries and they're dead, we're throwing a dead capsule at the Earth.
Our next milestone, we'll be expecting that drogue parachute deployment. Quite a challenge to track this as it comes searing into Earth's atmosphere.
I can tell you what we expected to happen. The drogue chute is commanded to deploy, and then 360 seconds after the drogue, the main chute. I could not see whether or not the drogue was deployed in the imagery that I had available in real time in the ops room.
You can see our SRC streaking in. We see.
CDL milestone, we have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that.
And I knew the moment the chute opened, that was it. It was overwhelming relief, gratitude, pride, awe, and really trying to convince myself that I wasn't dreaming.
And touchdown of the OSIRIS-REx sample return capsule, a journey of 1 billion miles to asteroid Bennu and back, has come to an end. And you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. And there is landing of our first helicopter at the site, and the rest of the team is closely behind, ready to land at the recovery site to begin operations.
Yeah. Looks good, huh?
Yep. Look, heat shield down.
Yeah.
Heat shield down, sitting straight up.
Parachute right next to it.
I was fortunate enough to be one of the first people to lay eyes on the capsule, and boy, did we stick that landing. It was just sitting right there.
Oh yeah, look at that.
We think we've got a lot of sample in that science canister, and we can't wait to crack into it.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And it is off the desert terrain, in the air, with the SRC in tow.
OSIRIS on 3. 1, 2, 3.
OSIRIS!
This is the final leg of the journey of the SRC. It has been loaded on the helicopter a few minutes ago, and as we speak, team members are staged and waiting just outside that clean room, ready to get that SRC back on the ground once more.
The key objective for me, and one of the driving objectives of this program, is to try to understand, did carbon-rich asteroids like Bennu deliver the compounds that may have led to the origin of life on our planet, the origin of Earth as a habitable world? I was there when it was nothing but a PowerPoint on a slide in a proposal that we were submitting to NASA with this dream that we were going to bring back samples from Bennu. So it was amazing and emotional. As incredible as it seemed all those years ago, it came to be. The Earth Gravity Assist was a great exercise for the team. So it was the first time everybody showed up here in Tucson because we were doing science operations here. And so it just had that vibe, like all of a sudden everybody's here, we're excited, we're just getting ready for Bennu. And this is just a dry run, a rehearsal to check out all of our instruments.
That's great.
And then that picture of the Earth showed up on the screen. And it was like a Carl Sagan moment. It was like, you know, the pale blue, the famous pale blue dot. And it's, you know, you just see it. It's like, that's us, right? And that's everybody on Earth is in that one picture. And you just realize how fragile it is, how beautiful it is, how rare it is. And really, you know, I wish everybody could have that moment because I think we would take better care of ourselves and our home world.
Captain was turning around. Oh, that view is tremendous.
And I think we need to appreciate that, this is a gift that we've been given, to be alive, to be conscious on this beautiful world, to have all of these capabilities, to learn about our place in the cosmos, to wonder about it. They call it the overview effect, right? When you see the world from space. The scale of everything. The Earth seems really big, but it looks so tiny when you see it like that.
Hey, Tom.
Hi, Erika.
So great to meet you.
Nice to meet you.
Thank you so much for having me.
You're welcome.
I'm really excited. So tell me a little about the lab.
Yeah, so welcome to the Kuiper Astromaterials Analysis Facility. This is where we can look at the Bennu sample all the way down to the atomic level.
All right. I haven't been waiting 4.6 billion years for this sample, but I am very excited.
All right, let's go. All right, come on in. Okay, so this is the lab where we have visible light microscopes and also an electron microscope where we can look at the sample and get a first pass sense of what it might contain.
Okay, so are we looking at actual samples from Bennu?
Yeah, so this is literally mineral grains that were collected off the surface of the asteroid.
Okay, so can we look at some
absolutely.
samples?
Definitely, let's go look at samples. They're over here. So before we actually touch the sample, we want to put on some gloves.
Got to be extra careful with these.
Absolutely. And if you look at it, you can hold this now. And if you kind of hold it up to the light and look through, you'll see the dark Bennu dust.
Oh, wow. Dust from another world.
Exactly.
Is this going to help us figure out the origins of life on Earth?
Yeah, it certainly should help shed light on the kinds of molecules, organic molecules that may have been delivered to the early Earth.
Seems like a really good reason to go all the way out there and take a piece of an asteroid and bring it all the way back.
Absolutely. Why don't we go to one of the other labs where we can get really close at the most fundamental level, which would be the atomic level.
All right. I love atoms. Let's go.
Let's go. Okay, so welcome to the Transmission Electron Microscope Lab. It's a large instrument. It's the highest resolution instrument in the facility, and this one is capable of seeing down to the atomic level.
So is that what we're looking at in this picture that's here?
Yeah, so what you're looking at here is actually a sample of a mineral called perovskite. And each one of these white dots are the atoms in projection, and you can kind of think of them as like strings of pearls.
So we're looking like those little dots are atoms.
That's right.
That's amazing.
It's amazing, yeah. And objects like this have been radiometrically age dated to 4.567 billion years old.
Like when the sun was forming.
Exactly. The earliest stages of the solar system.
Your whole lab setup is really astounding. I feel like the very precious asteroid samples are in really good hands with you.
Oh, thank you. Yeah, and it took years to build the facility, and we're really excited about what this next several months and next couple of years hold.
Well, I appreciate your time so much. Thank you for giving me this incredible tour, letting me hold a sample, which is probably one of the highlights of my life.
That's great. You're welcome. Pleasure to have you.
Yeah, thank you so much.
Thanks.
Next up, I'll be visiting some of NASA's official planetary defense officers. These are scientists from the University of Arizona's SPACEWATCH program who are scanning the night skies, looking for asteroids that might one day impact the Earth. These people are going to save civilization. So check out our story on them and then come meet me afterwards.
When we're observing, we drive up to the mountain in the mid-afternoon Then we will start up and do a walk around both telescopes to make sure everything looks good. The 1.8 meter and 0.9 meter telescopes that we use are on Kitt Peak. And the 0.9 meter telescope is actually the original Steward Observatory telescope that started off on campus in 1922. One thing we need to do is choose our first targets and then start up all the software that we need to operate the telescopes. Then we also do a pointing to make sure that we're pointing exactly where we want to be pointing in the sky. And then we're ready to start taking images of asteroids. I'm Melissa Brucker. I work for the University of Arizona in the Lunar and Planetary Lab, and I'm the principal investigator of SPACEWATCH. And we use telescopes on Kitt Peak to measure the positions of asteroids to make sure they don't get lost. Why don't we check out this one up here?
Okay. May I zoom in?
Sure.
Okay, so go ahead and stack the blink, right?
Yeah. It may possibly be rotating. It looks a lot brighter in the last image.
Yeah, and the stars appear uniformly.
So at SPACEWATCH, there are 7 of us who operate the telescopes, including me, and we can have anywhere between 24 to 38 nights per month on the telescope.
I always click this button, ping all, and dismounts. And these both should be normal. So as the lead engineer, I go up to the mountain once a month to start the run. Starting the run is an all-day activity where I go up there, turn on all the power, test all the telescope motions, rotate the domes, open the shutter, basically make sure it's going to work that night for the observer, whoever that may be. There are, I think, 88 steps total from starting up the telescope, observing all night, and shutting it down that the observer has to do every night to use and then safe the telescope at the end. Everything looks good. For me personally, it offers a way to introduce a cycle. Life is full of cycles, and this allows me to kind of get away from the daily grind, if you will, and just kind of observe. And when the sun sets, the domes can open. I do get that sense of awe looking up the night sky, and it is amazing how dark it is on Kitt Peak. You can actually see the Milky Way in all its glory.
It's really great operating the telescopes and seeing the images come in. Often the asteroids that we're looking at are not bright enough to be seen in one image. So we take a series of images and then stack them together at the point where we think the asteroid should be in each image. So we end up with a dot for the asteroid and a line for each of the stars. So we have a NASA grant that funds our observations, and it is part of the Planetary Defense Coordination Office. So our goal is to reduce the uncertainty in our knowledge of where the near-Earth asteroids are as an act of planetary defense. And some of the more famous asteroids we looked at are Didymos, the target of the NASA's DART mission, the Double Asteroid Redirect Test. The goal was to nudge the asteroid by impacting it with the spacecraft. So they wanted to deflect the asteroid so that if it was one that could hit Earth, it would be moved. So we're not superheroes, but by being funded by NASA, we do fall under the auspices of the Planetary Defense Officer.
What makes this job fun to me is being able to be part of the entire cycle of operations, from designing the equipment to building it, to testing it, to using it, to submitting the data. I really believe in what I do, that there are rocks flying around in space, and one day a big one will hit us. It's inevitable. And I don't lose sleep over it, but I am glad there are people looking. And I hope that we can build a system that gets better and more efficient every year, and one day might help save civilization. It's great to be a part of that.
It's pretty exciting to observe an object that is a potential asteroid. And when you actually see it on the screen, blinking across the images, you're like, I did the job and I'm saving the world.
Hello.
Mike, so nice to meet you.
Erika, nice to meet you. Welcome to the SPACEWATCH.
So thank you so much for having me. I'm really excited to hear about how you guys are gonna save civilization. So what's new in your work?
So we've been doing a lot of follow-up of the targets that our joint survey with Catalina Sky Survey has discovered on Kitt Peak. The goal is to find all of the 140-meter sized asteroids and near-Earth asteroids and larger.
So is this some testing that you're doing now?
Yeah, so right now we're developing a new camera system for the 90-inch telescope, one of the telescopes we use.
Okay.
And we're subjecting our camera to some thermal tests where you can see a bunch of squiggly lines going across the TV here.
Yeah.
We're keeping track of several parameters as we optimize the system.
So is this new work and the new camera gonna help you to better understand the orbits of these objects?
It'll allow us to increase our sky coverage. We can take them with a single picture is about 4 times as big.
Okay, so I have one last question for you. For everyone watching at home, should they be worried that civilization will be cut short by an errant asteroid?
Definitely no, you should not be worried.
You should not be worried because we're on it.
Well, I will sleep way easier tonight. Thanks so much for taking the time to talk to me. This was really fun and informative.
Thank you for coming over.
Thanks for stopping by.
Thank you so much. Thanks so much for exploring the solar system with me on this all-new episode of New Frontiers. I'm Erika Hamden, and I'll see you next time. Make sure to stay tuned for future episodes where we'll explore more of the incredible innovation happening here at the University of Arizona. And if you want to know what's happening with me, follow my Instagram @Erika Hamden.